Yesterday, we talked about the majority voting method, right? Today, let us take the discussion further and let's talk about the rank order voting, right? Rank order voting method. So what do we do in this? We have, there are people who are voting for the different alternatives, and each person assigns each allocation a certain rank. So in his mind that every allocation has a certain rank. So he has a preference for one allocation and not for the other. So whatever he prefers, he'll be giving the first rank to uh, to that particular allocation, and then the lower rank to the other allocation. So what you do is that you get the aggregate score for each of these allocations. I mean, you will add up whatever ranks which individuals have given, and as a society, will be choosing that allocation which has the lowest rank, right? So let me write this and then I'll give you an example. So each person assigns each allocation a rank. Each allocation a rank. We add up the allocation to his preference, right? And this is true for all the individuals. We'll be doing this to his preference of all individuals, I can say. Of all individuals, right? Then we get the aggregate score for each of these allocations. Then we get the aggregate score of each of these allocations. And that particular outcome is going to be socially preferred, whose score is the lowest, right? And say that one outcome is preferred or is socially preferred. Is socially preferred to another who has the lowest score, right? Okay, so what do we do? Let us just pick up one example. I'll give you one or two examples so that you understand what we are doing. There are three individuals, A, B, and C, and the ranks are given to the alternatives. So A is preferring X to Y to Z. B is preferring X to Z to Y. And C is preferring Y to Z to X, right? And then what you do is that you add up the ranks of these individuals. What you do is that you add up the ranks of, these allocations. So if you add up the ranks for X, so A has given first rank, B has given first rank, C has given third rank. So 2 plus 3, 5. Ranks for Y, A has given second rank, B has given third rank, C has given first rank. 6. For Z, A has given third rank, B has given second rank, C has given second rank. 7. So naturally, I mean, we have just said this, that society is going to choose the one which, that alternative which is the, which has the lowest score. So as a society, society will choose X because this guy has the lowest score. It has the lowest score, right? Okay. There is one drawback of rank order voting. There is one drawback of rank order voting. That is, if you introduce a new variable or a new allocation, then it may change the order of the ranks, right? So it can be manipulated by introducing a new alternative, a new allocation, right? So I'll tell you what is that. Let me just write one line. It can be manipulated by introducing new alternatives that change the final ranks of the relevant alternatives. Final ranks of the relevant alternatives. So what do you mean by this? You mean by this. So for example, there are 3 individuals, A, B, and C, and now earlier A was preferring X to Y to Z. Now we have introduced one more alternative, W. Right? So now these are the ranks. So he's still preferring that thing, but here there's new alternative which has been there. B was earlier preferring X to Z to Y. He's still doing the same, but there is new alternative which has come, right? C was preferring Y to Z to X. He's still doing the same, but we have introduced one new alternative out here. You take up the ranks again. You take up the ranks again, so it becomes what? The ranks for X. Rank is 2 plus 1 plus 4. 7. Rank for Y. Individual A give third rank, B give third rank, and C give first rank. 7. Rank for Z. Individual A gives fourth rank, individual B gives second rank, and individual C gives third rank. 9. Rank for W. Individual A gives first rank, individual B gives fourth rank, and individual C gives second rank. Is this right? 7. All right. Okay. So earlier, what is it that you have seen? Earlier, what is it that you have seen? You've seen this, that X was, as a society, X was strictly preferred to Y, and Y was strictly preferred to Z, right? Now, only among these three, only these three alternatives, X and Y to society, they have become indifferent now, and they are preferred over Z, right? So the preferences of the society between X and Y, they have changed, right? So by introducing a new alternative, the social ranking of X, Y, and Z, they have changed, right? So by introducing a new alternative, social ranking of X, Y, Z has changed, right? I'll tell you one more thing. This majority voting has the problem which is related to the formation of the social welfare function, that it may result in cyclical preferences, or it can violate transitivity. You would want a social welfare function which is not going to violate transitivity. That's the first problem. Rank order voting is actually giving you the problem that you would want a social welfare function which should satisfy independence from irrelevant alternatives. That is what it is going to do. Now, although I talk about those two things in little detail in some other recording in which I'll talk about the error impossibility theorem, but I want to give you one or two more examples, maybe a similar one, but just to give you an idea that the majority voting might lead to a problem of intransitive preferences. So you would want a social welfare function which is transitive, but sometimes if you take up majority voting, it can lead to intransitive preferences. Sorry. This is also called Condorcet Paradox. This is also called Condorcet Paradox. So there are, let us say, few voters, A, B, and C. And they're giving ranks to the three alternatives. So in the mind of voter A, small a is better than small b is better than small c. For B, small b is better than small c is better than small a. For capital C voter, small c is better than small a is better than small. Right. So these are the voting preferences. These are the voting preferences, right? So you apply a pairwise majority rule. If we apply a pairwise majority rule, right, then what happens? Individual A prefers A to B. Individual C also prefers A to B. But individual B prefers B to B. So A beats B. Similarly, B beats C. Similarly, C beats A. Sorry. What happens is that this is going to lead to intransitive preferences. This is violating the problem. This is violating the desirable property of the social welfare function, that social welfare function should be transitive, because if A is preferred to B, B is preferred to C, then if preferences were transitive, A should be better than A should be preferred to C. But what is there? C is preferred to A. You cannot find out the best bundle, right? So please write, but this violates but this violates a desirable property of social welfare function, namely transitivity. Namely transitivity, right? Achha, the ranks which we have added, the way we have added these ranks, na? So this is also called Borda count. Borda count or Borda rule. That is, you have just found out what are these ranks, and you're going to choose the one which has the lowest Borda count, right? So if you want to just have a Borda count for this, for small a, it will be what? 1. Individual A is giving rank 1, B is giving rank 3, C is giving rank 2. 6. For B, individual A giving rank 2, individual B giving rank 1, individual C giving rank 3. 6. For allocation C, individual A giving rank 3, individual B giving rank 2, and individual C giving rank 1. 6. So the Borda count is there is a three-way count, a three-way tie, right? So there is a tie, and this is not surprising because you're not able to find out the best bundle. That is the problem. Taking the discussion a little further, but Borda count has a little. There's another problem with the Borda count. So if you have individual A, B, and C, individual A, B, and C. So I'm just giving you an idea before even telling you about the independence of irrelevant alternatives. And there is like this. So it is A, B, C, D. So we have introduced one variable, B, C, D, A, A, B, C, D. Right, Vita? So now if you just find out the Borda count, if you just find out the Borda count, what will you get? A is what? For A, individual A is given rank 1, B has given rank 4, C has given rank 1. So 1 plus 4, 5, 5 plus 1, 6. Right. Similarly for B, A has given rank 2, B has given rank 1, and C has given rank 2, right? So it is 5. For C, individual A has given rank 3, individual B has given rank 2, individual C has given rank 3. For allocation D, individual A has given rank 4, individual B has given rank 3, and individual C has given rank 4, right? 11. So if you apply Borda count to this profile, of course, B is going to be chosen, right? B is chosen. As per Borda count, right? But now suppose you do one thing. That you eliminate C and D. But now suppose we eliminate C and D from the consideration. Then what happens? So let me just form this. There are 3 individuals, A and B. There are 2 ranks, which you can give rank 1 and 2. So C and D are gone. You're only left with what? A, B, and C. Okay. C and D are gone. So it is A, B, C and D are gone. B, A, C and D are gone. A, B, right? So what do you have? Ranks for allocation A. Individual A gives rank 1. Individual B gives rank 2. Individual C gives rank 1. So 1 plus 2, 3, 3 plus 1, 4. B, for allocation B, individual A gives rank 2. Individual B gives rank 1, and individual C gives rank 2. 2 plus 2, 4, plus 1, 5. Are you seeing the beauty? You now, as per the Borda count, A should be chosen, even though B is available. Even though B is there, but you're choosing A. Now, A wins. Even though B is still available. So this is violating what? This is violating independence of irrelevant alternatives. It is violating independence of irrelevant alternatives, or it is violating the principle of pairwise independence, right? So what it states is that the socially chosen outcome should not change when the unchosen option are eliminated from the profile, right? So it states that socially chosen outcome should not change when unchosen option are eliminated from the profile. Right. So C and D were eliminated from the profile. It should not have affected the uh, the societal choice, but it had. So this is what independence of irrelevant alternatives is. But I'll talk about this more when I'll be doing arrow impossibility theorem. Right. Thank you, Beta.